Hello again, fourth graders, and welcome back to Math Workshop. Today we're going to continue our conversation about fractions and decimals. For the past few days, as you know, we've been working on writing fractions as decimals using our knowledge of base 10 because we know that fractions and decimals are interchangeable. They mean the same thing, they just look a different way. Today we're going to talk about, you know that in every unit we do a lesson on conversion. We're learning how to convert between different units of measure. Today we're going to use what we know about tenths and 100ths to do some conversion using the term meter. Now, here in the United States, we don't use what's called the metric system. We like to do our own thing and be our own way. And so we typically use different forms of measure in order to measure length. Remember, we did that earlier, I believe, in Unit 1, where we learned how to convert between inches and feet and yards. But in every other country of the world, they use what's called the metric system. And they use the metric system to measure liquids, and they use the metric system to measure length as well. So today we're going to take a look at what we know about tenths and hundreds, and we're going to use that information to convert units of measure, specifically units of length, using the metric system. So first we need to think about, okay, let's get some context. What is a meter? What does a meter look like? Well, you've probably seen in our classroom that really long, giant ruler that we usually keep up on the whiteboard. It's a long, sometimes people call it a yardstick. Other people call it a meter stick. The terms are not really interchangeable. A yardstick is just a little teensy bit different than a meter stick. But if you're thinking of that long, giant ruler at the front of the classroom, you probably are thinking of the one that is about 3 feet long. It's approximately the length of 3 rulers that we would use in the classroom. That's not exactly the same thing as a meter stick, but they are sure close. So I drew a picture of that just to get you imagining in your mind the kind of measurement that we're talking about. It's a really long ruler stick that is about the same length as 3 regular school rulers put together end to end. Now, a meter stick is a little teensy bit different. It's just a smidge longer than a regular yardstick. So we'll need to know that information when we go forward doing what it is that we're doing today. So we have to think about in terms of our conversions, friends, we need to be thinking that 1 meter stick, that really super long ruler, is going to be representative of 1 whole. So for the past few days, we've been thinking about 1 whole in terms of the hundreds grid, or the 10 sticks longs within the hundreds grid. And we've also been using that example of money, 1 whole being $1 bill. So today we're going to kind of continue using that idea of wholes, but in this case, we're going to think about a term related to units of length, 1 meter. So in this case, when we're talking about 1 meter, 1 meter will represent 1 whole. So today we're going to think about how we can break down that 1 whole into tenths and into hundredths. Fractions where we have 10 as the denominator, and fractions where we have 100 as the denominator. And we know that once we know what the fraction is, we can also write it as a decimal. So we'll be doing all of that work today, using all of our skills from the past few lessons. So I want to show you this picture here. I've drawn an example of a meter stick. So here's my example of my meter stick. And I've only shown you, of course, my meter stick would be longer than the desk that I'm working on. So I just put the very first 2 parts of our meter stick down on my paper. So you'll have to imagine that this meter stick is going to go on and on and on for almost 3 feet. That's almost the width of a door. So a meter stick is about the size of a doorway entrance. So try to imagine the door to your bedroom, or the door to the front door to your house, or the door to our classroom. That's about a meter. So you can imagine that my page is going to be just a small part of that meter stick. So if 1 meter stick represents 1 whole, we're going to concentrate today how to break that 1 whole into individual parts. So if I asked someone to come to the front of the classroom and use our long 10 sticks like this, and I asked you to put your long 10 stick on the very zero mark of our meter stick, what you're going to notice is that one long 10 stick from end to end is going to take you from the zero mark of your meter stick to the 10 centimeter mark. That means if I were to take this little tiny long 10 stick and break it up into its individual unit cubes, that means that I have 10 individual unit cubes lined up end to end from from the zero end of the meter stick all the way down. I would have 10 individual little unit cubes, the length of a long. So imagine if I lined a meter stick up on my board and I used one long 10 stick. We know that a meter is approximately 3 feet, which means we know that that's going to be more than 30 inches. We can use what we know about conversions to recognize that one 10 stick, one long that has 10 parts in it, is one fraction of our meter stick. So we have found that 10 longs is how long it takes to go the whole length of the meter stick. That means one long is a fraction. One long 10 stick, like this one here, is actually one part out of 10 parts that I would need. So if I lined all my 10 sticks up end to end to end with no gaps and no overlaps, it would take 10 sticks end to end to make 1 meter stick. So when I use what I know about tenths and hundredths, one 10 stick, one long, is 1/10 of a meter. So if I were to write that as a decimal, I would write that as 0 and 1/10, 0.1. But we're also operating within hundredths as well. So if I break that 10 stick down into its individual unit cubes, I would label each one of these marks on my meter stick as 1/100th, because I know it takes 10 little tiny unit cubes to make one long. So I'm using what I know about multiplying in base 10. If it takes 10 little unit cubes to make one long, and it takes 10 longs to make a whole meter stick, I use my knowledge of base 10, multiply 10 times 10, and I can find out that one long is equal to 1 centimeter. The word centi, we know this, means 100. So it takes 100 of these little centimeter cubes, because the word centi means 100. It takes 100 of these little cubes to go from 0 to the end of the end stick. That means each unit cube is 1/100th of a meter, because remember, the meter is the whole. So just like we were counting in ones and in tens, the same thing applies. When we were using our knowledge of counting just to make fractions as decimals, we know that we were counting each little unit cube as 1/100th, kind of like pennies, right? And we know that each long or 10 stick was 1/10 because we were skip counting by tens, kind of like dimes. The same conversion tool can be used when we're talking about converting between centimeters and meters. 1/100th of the whole meter is 1 unit cube, just like 1/100th of $1 is 1 tiny cube, or 1/100th of a 100ths grid is 1 tiny little cube. And 1/10 of $1 is a dime, represented by a long. 1/10 of a hundreds grid is a long, and it takes 10 of these longs to make 1 whole meter stick. So each long is 1/10 of a meter. So we can use what we already know about converting within base 10 to do the work of converting between meters as well. So if we look on journal page 95, you're going to see a chart that looks like this. So what you're going to be doing today is you're going to be imagining if they give you a number like 36 centimeters, 1 centimeter, remember, means 1 little tiny unit cube. So if you have 36 of them and you break them into tens and ones like we did with money, tenths or hundredths, how many longs do you see? Remember that a long represents 1/10, like a dime, and cubes represents 1/100th. So you have to think, okay, well, if 1 whole means 1.00, and I don't have an entire meter here, I've only got one small chunk, 36 centimeters. How many tenths do I have? What digit in this number represents the tenths place? How many longs are there? Well, I know that it takes 10 of these longs to make 1 meter. And 1 long represents 1/10. So if I have 3 in the tenths place, that means I have 3 longs. 30, 3/10. So you start to see the value. If I had 36 of these little unit cubes lined up together, that means I would have 30 10 sticks. Now, how many individual unit cubes would I need? Well, let's look back at our number. If the number 3 represents the 1/10ths place, what's the digit that represents the 100ths place? You got it. It's the 6. So 6 is in the 1/100ths place. Now we know that the 100ths are represented by cubes. So how many cubes would I need? You got it. 6. How many longs did I need? That's right, 3. Now, how do we write that as a decimal? We know that it takes 300 centimeters to make a meter stick. So we don't have 1 whole meter. That means in the ones place where the whole numbers go, we'd have to write 0 because we don't have any. Did we have any tenths in the tenths place? Any longs or things that represent dimes? Yes, we did. We had 3. So the 3, just like yesterday when we were writing tenths and hundredths, goes in the tenths place. And the digit in the hundredths place would, of course, be 6. So we write that 36 centimeters is equal to 36 hundredths of a meter. 36 hundredths of a meter. Now I'm going to see if you can do this example on your own, but notice I'm filling in different boxes. So today I'm going to give you 2 longs, and imagine you had 7 individual cubes. What number of centimeters do you have? How can I use my knowledge of tenths and hundredths to write this number? You give it a try and see what you get. How would I write that in centimeters? If I have 2 longs, we know that 2 represents the digit in the tenths place. So that means I should have 2 in the tenths place over here and 2 in the tenths place as a decimal. If 7 is the number of unit cubes I have, I know that 1 cube represents the hundredths place, like pennies. So I need to put that in the hundredths place over here in my word. And I also need to write it in my decimal place. So now I can say 27 centimeters has 2 tenths and 7 100ths. And the way that we say that is 27 hundredths of a meter. 27 hundredths of a meter. So today, friends, you're going to use your knowledge and your skills from the past few lessons of writing decimals and fractions using base 10. And it's also going to ask you to use that same exact skill, but this time we're just operating instead of in dollar bills and coins and change, or in hundreds grids using tens and ones. This time we're using centimeters, where meter is 1 whole, centimeter is 1 100th, and a long is 1 tenth. So I would like you to try page 95 today. You've got some examples there in the book for you, so you can see an example for you as you try this work on your own, and then you'll do some comparisons to find out which one of 2 decimals is greater than, less than, or equal to. And then they're going to give you an example of a meter stick at the bottom, and you get to use your knowledge of decimals, reading decimals like this, to put dots with label letters on that meter stick to practice. So you're going to work on page 95 today. Then you'll go off to do your exit ticket after you've checked your work. When you're feeling confident enough to do that exit ticket, you can attack it. If you have any questions, as always, hit me up in the chat. And then once your exit ticket is complete, you can go on to work on page 96 for optional work, and then 97 is math boxes. All right, 4th graders, good luck today practicing your tenths and 100ths of a meter. Off you go.